Hi everybody and welcome back. So this week we are going to start talking about pandas, which is probably the single most important package you're going to be using in Python as a data scientist or as somebody interested in data. So at this point through this course, we've acquired data that we need from flat files, from JSONs, from APIs, from web scraping, from databases, and we've got data and it might look something like this. Now, it will probably look nicer if you pull data from a relational database with SQL. The reason why it will look better with SQL is because all of the work is done initially to clean the data before it goes into the database. But for many other situations, we're going to get data and it's going to look like this. In fact, this is the data that's going to be on your lab for this week. Now, we can't use this. We've acquired the raw data and we can't use it yet. And the reason why we can't use it, well, there are a number of reasons. The column names are not intuitive. I have no idea what HI1 means. The numeric codes inside this table represent categories, and I don't know what number refers to what category. They're not labeled. There are values like 96 in here, which are used for missing values, and I would rather that they just get coded as missing. We might need to take a selection of the rows, only certain rows are relevant to us, or a selection of the columns. And so for all of these reasons, and then there are others in addition, we can't use the raw data. That means that we're going to have to do some data manipulation or data wrangling. So data manipulation or wrangling or data management, this term consists of all the steps that we need to put raw data into a form that can be explored, can be visualized, and can be modeled. This is the most time-consuming part of most data science projects. As time-consuming as it can be to acquire the raw data, cleaning that raw data takes even more time. If you think back to the very beginning of the course, together the data acquisition and the data manipulation stages took up 80% of a data scientist's time. I think that the only time I've ever seen a raw data set that was clean was when I was working on a class assignment or when I was working on Kaggle. In the real world, clean, raw data doesn't exist. Mistakes happen at the data cleaning stage, and if they do, they can corrupt the entire analysis. If you feed corrupted data into a machine learning model, no amount of machine learning magic can save the analysis. But that said, I don't mean to sound overly negative about this. I think data manipulation can be fun. It could be like putting together a puzzle. We just have to know what the right moves are and what the right combination of those moves are. So let's talk about an example of why it's so important to get the data management right, and then we'll talk about the techniques in the next videos. So there's a really famous talk, infamous, but famous. The study that these guys were talking about was infamous, but these two guys are famous. And you should watch it. Here's the YouTube link, and I have a link to it in the notebook for this week. Here's the case. Here's what happened. They talk about what can go wrong when people working with data aren't transparent about all their data cleaning steps and all the steps that happened between loading the raw data and getting to analytical results. So Baggerly and Coombs, they were talking about this paper, Genomic Signatures to Guide the Use of Chemotherapeutics. This paper appeared in a really prominent medical journal. It claimed to show how treatments for childhood leukemia could be tailored to patients based on the specific genomic information in the patient's DNA. Basically, that means some cancer treatments work for some people and they don't work for others, right? Can we dig into your DNA and determine what kinds of treatments are going to work for you? It would be a big deal if we could figure that out. And that's what this study claimed to discover. It was an important finding. It was published. it got a lot of attention. And so Baggerly and Coombs tried to replicate that study. They weren't trying to replicate it in the sense of recruiting a new sample. They wanted to just reproduce the study's results from the same raw data that those authors had put together. The problem is there was a black box here, right? The authors did not provide any scripts or discussion of what they did to the data prior to running the testing models. So we started with the raw data, and then there was a big question mark, like what did they do to the raw data? And then that led to the results published in the paper. So what Baggerly and Coombs did was they use the word forensic, and they don't mean it as a compliment. They had to dig around the raw data, trying any number of ways to clean it in order to get to the same results. So they worked on that for a long time. They were unable to get the same results unless they made mistakes on purpose. So they eventually found two errors, right? In order to replicate the results, first they had to create an off by one error. So all of the data that refers to one gene was listed on the row that's actually beneath the one beneath the label for that gene, right? So if we have gene A, all the data for gene A are listed with gene B, and all the data for gene B are listed with gene C, and off by one error. An off by one error happens a lot when you do things like copy and paste from Excel spreadsheets. And they think that's what the authors must have done. They must have just copied and pasted their data. Second, the treatment was coded as either 1 or 2, right, for the treated genes, for the not treated genes. But somebody along the way confused what 1 and 2 meant. So the treated rows in the data set were listed as control, and the control was listed as treatment. And that is a huge mistake, because any results that you find at that point are the exact opposite of the truth, right? Because it's the effect of being in the control group, not the effect of being in the treatment group. So in other words, what the positive effect that these authors found was actually a treatment that harms people, not helps people, because it's the opposite, because of that second error. By the time Baggerly and Coombs made that discovery, on the basis of that article, there were drug trials being used with real childhood leukemia patients. That is a big, big problem. And so please watch that talk, because Baggerly goes into all the different ways that he and Coombs tried to sound the alarm and to get those drug trials stopped. But it only stopped... There were so many stages in which it should have been stopped, and then it didn't. And it becomes this whole story about people hiding their research mistakes because of reputation and grant money and things like that. It only stopped after it also was discovered that the principal investigator in that original study lied on his CV about being a Rhodes Scholar. Like, that's what got people's attention. Whatever. So what exactly went so wrong here? First, there are dumb, typical mistakes that people make when they use spreadsheets, when they use Microsoft Excel. The off by one error, confusing ones and twos. Those are pretty typical kinds of mistakes. But there was also laziness. There was no effort to document the steps that were taken. So even if they were working in Excel, if they were meticulous about documenting their steps, it could have been caught much easier and fixed. Then there was self-interest and ego that kicked in, covering up the mistakes instead of risking the penalties for correcting those mistakes. And it made matters worse. And then finally, and I think this is the biggest problem of all, there's this idea of magical thinking when it comes to data. Because the work involves data, there's a tendency by most people to simply believe that the work is correct without digging into it. So, that's an issue. So if we're going to be working with data, how can we avoid the mistakes that Baggerly and Coombs discovered? So one, mistakes are inevitable. But if we use code like Pandas instead of pointing and clicking, it's going to be easier to see the mistakes and to go back and correct them. Two, if we document our steps as we go along with the Jupyter Notebook, we'll be transparent we'll be able to show anyone exactly what we did with the data. And then we can feed our egos in a different way, right? If we have a really nice notebook that describes all these steps and just shows that we're being really careful and professional about it, I think that's pretty impressive itself. Jupyter Notebooks can create a really nice portfolio piece. And explaining ourselves as we go along, that goes a long way towards dispelling the anxiety that people have about data, and so we're not going to have that sort of magical thinking.